Max priority queue. Let us discuss about the concept and operations. Concept of a max priority queue. A max priority queue is an abstract data type where every element is assigned a priority. The element with the highest priority, or the maximum key value, is always served first. In simple terms, each element has a key that represents its priority. At any time, the element with the largest key is easily accessible and removed before others. Unlike a normal queue, the order of insertion does not matter. Only the priority decides which element comes out first. Common internal implementations. A max priority queue can be implemented using different data structures. It can be implemented using sorted or unsorted arrays. In an unsorted array, insertion is fast, but finding the maximum element takes more time. In a sorted array, the maximum element is easily accessible, but insertion is slower. It can also be implemented using sorted or unsorted linked lists. Unsorted linked lists allow fast insertion, but deletion of the maximum element is slow. Sorted linked lists allow quick removal of the maximum element, but insertion takes more time. The most efficient and commonly used implementation is the binary heap. In a max heap, the largest element is always at the root. This allows fast insertion and deletion operations. Another implementation is the binary search tree. In a binary search tree, the maximum element is found at the rightmost node. However, performance can degrade if the tree becomes unbalanced. Conclusion. Among all implementations, the binary heap is preferred because it provides the best overall performance for priority queue operations. Operations of a max priority queue. A max priority queue supports several important operations that work based on priority. Insert S(x). This operation inserts an element x into the set S. It means that the new element is added to the priority queue. After insertion, the queue rearranges itself so that the element with the highest priority remains easily accessible. Maximum S. This operation returns the element in set S that has the largest key, or highest priority. It does not remove the element from the queue. It only allows us to see which element currently has the maximum priority. Extract max S. This operation removes and returns the element from set S that has the largest key. After removing the maximum element, the queue reorganizes itself to maintain the priority order. This operation is commonly used when the highest priority task needs to be processed. Increase key S(x, k). This operation increases the priority key of element x to a new value k. The new key value k is assumed to be greater than or equal to the current key value of x. After increasing the key, the element may move upward in the queue to maintain the max priority property. Conclusion. All these operations ensure that the element with the highest priority is always quickly accessible in a max priority queue. Example of a max priority queue. Suppose we have the numbers 15, 35, 10, 40, 6, and 5 stored in a priority queue. First, we arrange these numbers from the largest value to the smallest value. After arranging, the order becomes 40, 35, 15, 10, 6, 5. In a max priority queue, the largest number always has the highest priority. So here, 40 is the highest number, and it receives the highest priority. Before sorting, the elements are stored as 15, 35, 10, 40, 6, and 5. After sorting in descending order, the elements become 40, 35, 15, 10, 6, and 5. In this sorted list, 40 holds the top priority. while 5 is considered the lowest priority. This example clearly shows how a max priority queue always gives preference to the largest value. Explanation of the code. This program implements a max priority queue using an array. First, we include the standard input-output header file. Then, we define a constant named max with value 100, which represents the maximum size of the priority queue. An integer array named PQ is declared to store the elements of the priority queue. A variable named size is initialized to 0 to keep track of the number of elements in the queue. Insert operation. The insert function is used to add an element to the priority queue. First, it checks whether the queue is full. If the size is equal to max, it prints that the priority queue is full and returns. If space is available, the element is inserted at the current size index of the array. After inserting the element, the size of the queue is increased by 1. Maximum operation. The maximum function is used to find the element with the highest priority. The first element of the array is assumed to be the maximum initially. Then, the function compares each element in the array with the current maximum value. If a larger element is found, the maximum value is updated. After checking all elements, the function returns the largest value present in the priority queue. Conclusion. This code demonstrates a simple array-based implementation of a max priority queue. Insertion is fast, but finding the maximum element requires scanning all elements. Delete maximum operation. This function is called extract max. It is used to remove and return the element with the highest priority from the priority queue. First, the function checks whether the priority queue is empty. If the size is 0, it prints that the priority queue is empty and returns -1. If the queue is not empty, the first element is assumed to be the maximum. A variable called index is used to store the position of the maximum element. The function then scans all elements in the array. If an element larger than the current maximum is found, the maximum value and its index are updated. After finding the maximum element, it is removed from the queue. This is done by replacing it with the last element in the array. The size of the queue is then decreased by 1. Finally, the function returns the maximum element that was removed. Display operation. This function is called display. It is used to show all the elements present in the priority queue. First, it checks whether the queue is empty. If the size is 0, it prints that the priority queue is empty and returns. If elements are present, it prints a message indicating the priority queue elements. Then it displays each element one by one. Conclusion. These operations allow the priority queue to remove the highest priority element and display the current contents of the queue. Main function explanation. This is the main function of the program. First, several elements are inserted into the priority queue. The values inserted are 15, 35, 10, 40, 6, and 5. These values are stored in the priority queue using the insert operation. Next, the display function is called. It prints all the elements currently present in the priority queue in the order they were inserted. Then, the maximum function is called. It finds and prints the element with the highest priority. After that, the extract max function is called. It removes and returns the maximum element from the priority queue. Finally, the program ends successfully.